Till the numpy, our things are clear, right? So the simpy, the numpy, and all. So today we'll be learning about the data structures, okay, and how to uh, come with a sheet, or you can say a spreadsheet in Python, working with some different libraries for pandas, okay. So the very beginning thing is to import the pandas, right? And this is a package or a module or a library, you can say, which gives you an interaction with the data, which gives you an interface to interact with the data, to modify your data, to clean your data, to analyze your data, right? Okay. Okay. So they gives you all these information regarding that. So, like if you want to know more for a library or a package, I have said that you write there and you'll be getting up the things. So what is this pandas? So it's a Python package providing fast, flexible and expressive data structures designed to make working with the relational and the labeled data. So there you have basically two kind of data: unvariate data and bivariate data. Unvariate data are where you work with only one of the data, and when you work with more than one data, that is a bivariate data. Okay, that is a bivariate data. So we'll be focusing on the series, we'll be focusing on the data frames and all. Okay, fine. So let's just start this. So if you just start up with the series, now what are series? Hmm? What are series? Now these are a one dimension array like a structure. Okay, always of a one dimension, and I get it there. So let's say making a series sp dot series. Okay, we need a series, and then you write 1 2 3 4 5, whatever you want, write your data exactly. So series is a one dimension nd array with labeled axis, okay, with the axis labeled. So labels need not to be unique, or it must not be a hashable type like a comment and all. So there you can just define a series. So it takes parameters as index or data type or name and all. Okay, fine. So we'll run this. Something invalid is there. Yeah. So write data and whatever you want to write there, you can just mention it. Okay. Now let's just say if we are making a series, okay, and we are defining an series as like, let's say, to be 1 2 3, and this x, which is a 1D array, right? So you can get a series of 1 2 3 with the index numbers as 0 1 and 2, and the data types to be the integer 64. And you can easily mention or find out into indexings and all. Okay, fine, right? You can do up the indexings, and a lot of things are there in the series. So if we just find like what is the index of the series, so x dot index. So index starts from the 0, stop at 3 and goes with an interval of 1. Okay. Now what about the values it is having? So what are the values of this x? So it is 1, 2 and 3, array of 1, 2 and 3, and since you can see this is in one dimension 1. What is the data type this series is having? This is of integer 64. What is the shape of this series? 3. So it returns a tuple of the shape of underlying data, right? So 3 elements are there, negating the 3. Very quite good, right? Now there is a term called as n bytes, that is series dot n bytes. Now this n bytes return the number of bytes in the data you are having. So 24 bytes. Okay. Now what is the dimension of your series? One dimension. Obviously, a series is always a one dimension array. Okay. Now, what is the size of the series? 3. That means 3 elements are there, right? And then if we write that we want some transpose of the series, you can write it as x dot t. So transpose will do if a series is having such things, right, and you want to transpose it, you can use dot t. And you want to see like how much memory this series is storing, so you can write x dot memory usage. So it returns the memory usage, right? So memory usage can optionally include the contribution of the index and you can say the elements of the object type. Okay, fine. So let's say if I write it as s is equals to vd dot series of a range of 3, and we say s dot memory usage. Okay. Yeah. So memory usage. You'll run this and you'll get the memory usage. It is doing 152. Right? 5, 168. So changes accordingly. Okay, fine. So a series can be always of one dimension, and every series is having a name, right? So if there is no name of the series, you'll be getting up none there, right? And you can even rename a series if it is not even having a series. Name is there, right? So, right, let's say that you are making a series that like x is a series. Now, if you say x dot name, so nothing is being generated, right? Because there is no such name for this series. Now let's say this x is pd dot series, and you say to be 10, 11, and 12, and there you write your d type, that is data type. You can define it. Let's say I want a data type of float 64, and I define the name as some random float numbers. Okay, sorry, MP is not clear. Okay, so now if I see my x, it would be a series of 10, 11, 12 with a name of random float numbers. Now, once you have defined your name and like you want to rename it, you can just write x series dot rename, and that will be done. So it will be a renamed series now, right? But that is only for the printing, right? It will not be stored, right? If you want to store, you will have to write it x is equals to that x. Otherwise, it will be the same as for whatever the previous values were. Okay? Now, like you want to copy something from a series, that is very easy, right? Let's take y, which is a copy of x. Could be done very quickly. So y would be a copy of the x series, exactly the same. Okay, you can even find the Boolean values of a series, right? Boolean values means that if I say pd dot series, and if I write there true dot bool, it's true 1, right? So in that case, bool cannot act on non-boolean single element series, so it should be always a boolean value. So for true it's true, for false it's false. Okay, right? So it can work with this, right? So what this bool does, it returns the boolean of a single element of a series or a data frame, and we'll be looking up to the data frame. What is a data frame particularly? Okay. Now, if you have any series and you want it to convert to a list, so you can write this to list, this to underscore of list, and that will be converted in a list. That will be just converted into a list, right? And if you want the things to be converted in timestamp, right? So write y2 underscore of. So you have to give up the things, actually the range, index and all, for a timestamp. We'll do it in the data frame. We'll see it there. Okay. If you want to check whether a series is empty or not, right? So that too also works on a data frame, right? The code is like you will be writing it's that y dot empty, and that will be giving you some results. Like if it is empty, it is true. If it is not empty, it is false, and like that. Like if I write pd dot series, so this is true, right? Because there is no object or no data inside that series. Okay, that is how series works. You can convert it in the list, or you can combine, you can do some operations, you can group by the things, and lot more you can do. Like let's say you want to find the mean, so np dot mean of x will give you the mean, right? Even if it is a series, you can just combine the things to get up the values. Now with what you can make up a series, let's say there is a dictionary, and it is like, let's say there are some subjects, this is mathematics or physics. Okay, I like giving some of the values here. Then you say that you want a series of the data which is di, and it should be the series of the data, right? The physics is 45, chemistry 23, mathematics 98. Now what we can see, like when we write any series, we can see 0, 1, 2 as the index positions and the index numbers over there. So if we want to change this 0, 1, 2, we don't want from 0 itself, right? We want from starting from 5 or any such defined numbers what we want. So what we can do in that case, like when you are making a series, as I said, you have various parameters. So you can write up your data what you want. Let's say your data is your data is a linspace of 2 to 4 numbers, exactly 4 numbers, right? Then you can write, if you just run this, so what you can see, so numbers from 2 to 4, equal space numbers. If we take it for 14, that's fine. So the 14 numbers from 2 to 4 with some equal spacings. Okay, but the series remain the same. Now let's say making it for this 3. So 3. Okay, and writing the index to be, okay, don't write it len space, just write it as 5, 6 and 7, and the name if you want. Okay, we'll run this and you can see a series with 2, 3 and 4. Why? Because with the 2 and 4 we are working with some 3 numbers, so exactly the 3 numbers we are getting, and the index to be 5, 6, 7 what we have given, and the name to be the series with len space and changed index and the data types. I think this is clear. Okay, fine. Similarly, there are a lot of things like if I say us for a series dot value underscore counts. So it gives value count give you like the occurrence or the count of the individual or unique number of things inside a series or any data frame. So like how many 12 are there? There is 112. How many 11? 111. How many 10? 110. So if I say this is C and this is equals to PD dot series, and let's say the series here the data is equals to 1 1 2 2 3 4 5 6. Okay, so data belongs like this, right? And let's say we write the index to be 1. How many numbers are there? 8. So A B C D E F G H. Okay, and let's say name is equals to for value counts. Okay, so what is C? You can see the numbers from A, B, C, D, E, F, G, H, and the name for value counts and all the numbers, right? Now, what is the motto of writing these things? So, I actually want to make you see how a value count works. So, now you can see that it is giving it that 2 is for 2 times, 1 is for 2 times, 6 is for 1 time, 5 is for 1 time, 4 is for 1 time, and 3 is for 1 time inside a series. I think that is clear. Okay. Now, as I said that a series can also be there with a dictionary, you can write it as s dot c dot keys. And you could get the keys, basically the index values, or if you write c dot index, let's do the same thing. Okay, fine. So that is like a dictionary is very important in case of making with the data and all. Now let's say we'll make a d which is c dot copy, and what is d now? That's all right. Copy of c. If I say in the d of 5, what is there? Oh, sorry, that is f. Has not been properly been copied. So d of 5 is 4. Okay, or you say d of f, that is 4. Okay, and now if I say that d equals, or I say d of 5 equals to 10. So if I see my d, it will be something changed, right? Now if I want to add up my c and d, like one of the series with c and one of the series with the d. Okay, so let's say if I write c plus d, so you're getting up the values. 1 plus 1, 2, 2 plus 2, and 4, 4, something like. Only the change can be seen in the case of 14, right? Because there is 10, and what is the c of 5 and what is the d of 5? 4 and 10. So obviously it will be 14, right? And a series can also be added like x dot add y, like yeah, adding c dot add d. Nice. Hmm? Add it to the c and you will be getting up the results. So multiplication, divisions, and all you can write. Add, subtract, null, and divide. If you want to see a dot product between the c and d, you can just write c dot product of between. Okay. So, like if you want to convert a series to an NumPy array, obviously it is there, but still, if you want it to be there inside NumPy, you can convert it there. Hmm? So it would be like array of 1, 2, 3, and for the list, I have said how to make it there. So in a list, you can find the mean, median, modes, and all, right? So for making mode, you'll have to import from stats. Sorry, from SciPy. So stats dot the mode of this C. So mode array is 1 and the count is for 2 times. Okay. So stats of mode of B. Okay. Or the median. Median of the D. Mean of the D. And the sum maximum 3. Okay, so like this you can find up a lot of things inside a series. Even you can make it from the random things, right? If I write it as random dot, so one random number, similarly 5 random numbers. Okay, so let's say x is equals to pd dot series of the data, which is equals to random numbers, 5 random numbers. So this is x, which is equals to 5 random numbers. Let's say u is also equals to pd dot series of some data, which would be a random numbers of 5. So you can see up the u even. Now if I write u dot multiply this x, so you can get the things, right? If you multiply it, the u with the x, and so that's the result is there. But if I change it to the 6, if I see u and multiply this, you can see some nan here in case of this. Now what happened? The first 5 numbers are there in the x, but you are multiplying x with such a series which is having 6 numbers. Okay, you're multiplying a series with such a series which is having 6 numbers, and the series with which you are multiplying it is having 5 numbers. So 5 of the multiplications will be done successfully, but the sixth one will be not done, right? Because there is nothing inside the first one, that is, there is no sixth number inside the first, so it cannot take any number from there, so it would be a nan, that is not a number. So if there is no number, how can we operate, can we find the multiplication of that? So in that case you will be getting a nan. Okay, moving on. So like these are the operations on a series you want to see. Hmm? Okay, so like if you want to see that is there any null values inside your series or not, so x dot is na. Okay, so no null values. But if I write x dot multiplication of u and then find the null values, then you find one true thing, that is in the fifth position there is a true object, or there is a null object, you can say. Okay, that is how a series is being worked. Now coming up to the data frames. Okay, I hope series is clear to everyone. Hmm? Coming next. Now, when we talk about the data frames, hmm, when we talk about these things, so data frames are exactly a 2D structure. Okay, or you can say, if we just go in the way with this data frames, so this is a two-dimensional, you can say, size mutable or heterogeneous tabular data, which can hold various data types, and this data structure also contains the labeled axes, or you can say the rows and the columns, or the arithmetic operations on can be done on both the rows and the columns, like a dictionary or the series. Okay, so the parameters you are having in the data frame, right? If you just see pd dot, okay, this is a syntax of writing a data frame. So the parameters you are having inside the data frame is data. You are having index, columns, data type, copy, and all. Okay. Now, how these things are made and how to make a data frame and all, right? When I say this is a 2D, how it is created, right? Let's say we are making a dictionary. When the column 1, we are having value as 1. The column 2, the value is 3 and 4. Now we make a data frame, let's say for the TF, and that could be pd dot data frame. So pd dot data frame, and then you write your data. What is your data? So it's D. It's not compulsory to write data every time, but if you have a habit of writing this data, then it's nice. Okay. So if you see your DF, you could see there column 1, column 2, 1, 3, 2, 4, 0, and 1. And what is this? This is a data frame consisting of 2 columns and 2 rows. and the data is there. In the column 1 is 1 and 2, in the column 2 is 3 and 4, and so does the index numbers 0 and 1. If you use print this df, there you'll be getting something like this. Okay, so no tabular kind of things. So to info these things, right? So these are inferred as a data type of integer 64, right? You can see the data types, so you can find out the data types, right? So if you want to see the data types, you can write as df.data types. So you can get it there. The column 1 is having integer 64, the column 2 is having integer 64, and the data type is object. Okay. Okay, moving on. Now, to enforce a data frame inside a single data type, right? That is what we did in the NumPy and all. We enforce in within our parameters with our data types. What you can write it as, let's say this is df and this is pd dot t, and the data type, let it to be the integer of 8 bytes. Now we have seen that it can be there in the NumPy. So now we'll see the d types would be integer 8, integer 8. That is, you enforce the things to be there in your own data type what you define, irrespective of what it comes by default. Now we are getting the column 1, column 2 and everything like as the index value. Okay, now what if we don't define, so this was a dictionary in the case, so you are getting up your column 1 and column 2 as your index value. But let's say if it would not be a dictionary, okay, so what in that case? So there, let's just make a df2 and we'll make a data frame from an NumPy array. So let it be 1 to 3, or let it be a 2-dimension. So let it be 4, 5, and 6, and let it be 7, 8, and 9. Okay. You made this, and then just run this, and let's see what comes. So this comes as a NumPy array where you are having a data 1, 2, 3, 4, 5, 6, and 7, 8, 9. That is the 3 rows you are having, okay, and the 3 columns are getting to be 0, 1, and 2. Now if you want to change the columns which are getting by default, right, as the 0, 1, and 2, what you can do is you can put a comma there, and then you can define your columns to be, let's say you want the columns as A, B, and C. You can see your df2 to be changed from something and it to be A, B, and C. Okay, bye. So for any data frame, if you want to see up the index or if you want to see up the values, so you can write as df2 dot columns. So you're getting the column names, right? Similarly, df2 dot values to give the values, that is 1, 2, 3, 4, 5, 6, and 7, 8, 9, exactly the thing we are having there. So if you check here, like df2 is empty, so it is not empty, right? So if you want to see the excess, so these are the excess, right? The index thing, you can say the row is starting from 0 and going till 3, and about the column it is starting from A and going till C. Okay, so that is exactly in the manner of how you get the shapes. So when you find a shape, what do you get? Some rows and columns, like you get 2 by 3 or 4 by 5. What do you get there? That's some rows, 2 rows and 3 columns, similarly to this, right? Now if you say that df2 dot the shape, you get some 3 by 3, that means 3 rows and 3 columns. So these are the values of the rows and these are the values of the column. Okay, fine. Now what is the size of this data frame? It is 9. So total elements present inside the data frame to be 9. And if you want an information for more in the data frame, you can write this info. So what you can see there is a class, which this data frame is a class of a pandas host frame data frame, and the range starts from 0, goes till 2, having 3 entries. Data columns are total 3. So the column names are A, B and C, and every column is having 3 non-null integers. So the data types total are 3 integer of 64 bytes and the memory usage is 200 bytes. Or you can just write it as the individual memory usage. Okay, so like what is A using, what is B using, what is C using, and then the index. So 24 multiplied by 3 plus 128, so 200 bytes, including the index values. Now if you want to exclude the index, you can write only want to see up the uh, columns memory or the rows memory, you can just write index equals false. Okay, and you can see there. So without the index, how much space is it is taking? Sorry, this is 72. Okay, and this is memory usage including the index values too, right? Because index is also having its own uh, memory. Okay, fine. Now if we make a not a dictionary, sorry, if we make a data frame, let's say d types could be majorly of integer 64, float 64, complex 64, or you can say as object. What you see in the pandas, okay, you can see the data types at this, or you can see a boolean kind. Complex of 64 is not 38 times. So you can get the data about this, right? Now let's say our data is a dictionary and we are making a dictionary of data. So let's say t and np dot ones. Okay, and let's say the shape we want is some 5000, and what to do with this, let's change the type to t, right? So as type to t. And now what is t? I'll be defining it later, right? And after writing this, we'll write for T in data types. Okay, so for the T inside the data types, okay, something is missing up there. We'll write df as the pd dot data frame of this data. Okay. Now, if you look onto your df, what you can see is some 5,000 rows and 5 columns. Now, right? 5,000 rows and the 5 columns with individual data types. Now, how can a number be there inside an integer? So, integer could be 1, 1, 1, 1, 1, and so forth. The float could be 1.0, complex as such, object as such, and so does the Boolean values. Okay? So, like if I write some 5,000 numbers, if we want to see the first 5 values, now for any data frame in such a case, you want only the first 5 values, you could write it as df dot head. So it will give you the first 5 values of your data. And similarly, you want the last 5 values, you could write it as to be the tail. To get the tail. Okay, that is the last 5 values of the data. Alright, you want a single data, that is so one data. If you want, you can write that. Okay, so what is the memory usage of this data? So it says there is 200.3 plus KB of the memory usage of this data. So the integer are 5,000 and the data type is integer 64, right? Float are 5,000 and all are the same, right? So we are having all the data types which comes inside the pandas: Boolean, complex, float, integer, and object. So the memory usage, you are also getting it there. Now, if I write df dot memory usage, so I can see index is occupying some 128 bytes. Integer 64 is having 40,000 bytes. Float is having 40,000 bytes. Complex is having 80,000 bytes, and so does, right? Now, what is the value count? So like, what is the value count of integer? So integer is only having 1, okay, and that is for 5,000. Fine. Now, excluding the integers or excluding the index, if we write it as index is equals to false, so it would be integer of 64, float of 64, complex 128, object, and the booleans, and the data type we are getting as integer 64. Okay, fine. So these are actually, if you will focus on, like, these are in the bytes and this is in the KB. So there is a difference between the bytes and the kilobytes. Right, so just combine how many 40,000, 1, 2, 3, 180,000 and 5,000. So 40,000 for the 3 times, 180,000 and 5,000. It gives 20, 50, 0, 0 plus 128 including the index. So 20,000 sorry, 2,05,128, which gives you some 200.3 plus kilobytes. Okay, I think that is clear, right? So that is how we deal up with the data frames, the spaces and all. So like to see up the index or like to see the access. So if you just see the access here, so it would be the row starting from 0 going till 5,000 in the stepping of 1. The column is having in integer 64, float 64, complex, object, and the booleans, and the type is having is the object. Okay, fine. So with that context, we are getting up the things. Okay, now if I say when you go for finding up the shapes and the sizes of this your data frames, so you can write this data frame dot size. Okay. Similarly, we can find for the shapes. The shape is 5,000 by 5. So like this, we deal up with all of the data frames. We'll be going up with the real-time data. Like this is like a generated data, just finding up the things over there. Okay. So you can go with the real-time data given, right? Let's say that we'll do just a small program with that context. Okay. So let's make a list. Okay. Or let's say randomly right. Okay, fine. Let's make it a range of some 1, 2, 3, 4, 5 or 6. Okay, and what to do? And two to 4 and 5. Well done. So what is the shape of this V? 10,000 cross V, and if you see up the V, there are some of the Google codes. Okay, fine. So what we'll do, we'll write df as pd dot data frame, where our data is going to be V, and the index, not the index, the columns are going to be pd dot date range of, let's say, 2020. Today is 26. So 26/08, or let's say from 2020 and 8. write it for the next 10 days. Done, right? So if you see your DF, it would be some date ranges, that is 28 2020 21 8 2020 22 8 2020 till 29. Okay, and the 10 days, and you have got some Google codes, a lot of Google codes there, and that is not always the same. Okay, so a lot of there are Google codes. So how many are there? Approximately up to, what is the size of there if you just see? So 3 2 1. Alright, 1 lakh Google codes generated within some time. And if we just look on to the head of this data, so for the, like for 20 August, how many codes we have generated? So df dot, or df of 2020 8 and 20. So you can find there is some 10,000 Google codes generated on this particular day, like that, just a column over there, and you can even find up the value counts. So is there any change in, yeah, so we can find there are some codes which is also having 2 occurrence. All right, so value counts greater than 1. Dot, like, convert how many numbers are there which is you can say greater than the 1. So to list, so once it is converted to list, we can just count the occurrence of the true objects, and we found some invalid index. All right, some 1, and again something. Okay, there is a dot. So it is done, and once, like, if it is done, we can just count up the true results. So 54 numbers are there on the very first day, which has repeated for more than one time, right? So 54 codes are such which has been repeated up there. Okay, similarly you can find up for the next day how many codes were on the next day. 59 the second day, 40, okay, decreased, 23, 55, wow, 45, and there could be a lot of, right? So what is the focus to find, like, instead of writing up all these codes, what we can do is we can just write and see at what are the unique values of this df. Okay, cool. Or let's say what are the unique values of this 8 and 20 dot unique. So you get something length of some numbers. So what is the length of this unique numbers on the first day? 9946. So from 10,000, if we minus 9946, we get 54 numbers which were the duplicates, or you can say there are some of the, if we go for the 20. So 54 we can find up here, right? So that is exactly the copied numbers, right? Because that is a random generated number, so it could come as same. Okay. You can even find up the places where these are repeated up. How? Like if you convert this to an array, if you say this for df of 20 is equals to this dot 2 numpy. So once you convert it here, what df of 20 would be all of the codes over there. So if you just see the length of df of 20, so you can find it to be 10,000. Now we can easily find xyz as equals to np dot the unique of this df20, and we can find even to return the counts if they have been repeated up, how many there are, and also the index values to be true. And we could get it like x is equals to this, that is the length of the x as compared to the length of this df20 would be different. So length of the 20 was total 10,000 and the only unique numbers are 9946. So what is y then? Y are the index positions of the unique numbers. Okay. And what is z? Z are the counts you're having. So is there, how many numbers are there greater than the 1? So z greater than 1 is this, right? So what we can do is we can write np dot where this z value is greater than 1. So we can see all of these positions where the z value is greater than 1. Okay, so what we can do is we can copy up this whole list, you can say. Okay, and let's just make it as d equals to this. Equals it. Now for now how we can find this 329 is exactly the index number. So what is this x of 329? This code. So copy this code, copy this whole thing, and find up in the df of this 2020, 8 and even 20, where the values becomes as this. So it says wherever the value will be there, right, you'll be getting up a true result. So wherever the values will be, you can even find up, right, that np dot where in the, I think that's an array of df20, right? So where in the df20 this value becomes equals to this. So it is in the 358 and 1326. So we can write df20 of 358 and df20 of 1326. So you can find the same numbers at the both positions. Okay. So if you want to manipulate your data, to analyze up your data with that reference, you can go with that. Okay. Now, if I say that for, let's say this is O, a blank list, and I write for I in this D, for I in this D, O dot append the values of x of d, x of I, sorry, x of I. If you see your O, it will be a list of all the codes that has been printed for there. So these are the codes which has been repeated. These are the length of, let's see, the length of this O. So these are the 54 codes which has been printed for 2 times, right? Okay. Now, if we say for, let's say this is y, no, it's not y, let's say this is q. And you say for I in df20. Okay, sorry, for I in this O, print, or do one thing instead of printing, q dot append np dot where in the df20 is equals to this I. So see up your queue are having basically array of all the occurrence that is there. So at 2139 and all these positions are having the same things, right? So with this all we can just sum up, right? That is how we can use up with the data frames, and even we can find the, if you want to see at the head, sorry, numpy don't work with the head. So like with the first and occurrence, and you can find it there even with that array of all. Okay, let's say q of 0. So this is an array of this 0 of 0. Array this. So q of 0 of 0 is an array of this. Even of 0, you get it to 358, and even of 1. So q of 0 was a 358 value. Okay. Codes in the PDF format. Okay, so we'll be giving it to you in the drive, and you can go with that. Okay. So 358 is your first value, right? If I say q of 1 of 0, okay, and you can increment up the values till whatever it goes. So you can apply a loop for this, and then you can find other things there. So like 1 of 0 or 0 of 2 or with that respect. Okay? Or like q of 1 of 1 of 1. This is 1. It's 5646. So 2139 5646 you can apply there, and you can find there. Okay? Fine. So that is how you can work with this. Some random generated data, and then you can work it with this all. So if someone wanted this in IPNYB, I'll download this and upload it.